presentation is about electric vehicle efficiency versus price. And this is a statistics project by CJ Schoenmann. Now, why did I choose this set of data? EV adoption rates are on the rise. It is a technology that is more efficient, which makes it the next technological step for mankind. Also, it just is really intriguing for me. There is a lot of data on them, so it is a common field to run statistics on as it's a highly debated topic. There is huge market growth potential, so picking out individual companies to invest in based on this data would also be something I'm interested in. Now, why would this data be important to society? Well, it helps consumers choose which vehicle is best for them based on efficiency and or cost needs. Helps to track how the industry is progressing on average. This data will also help individuals anticipate energy costs for their new EV and which one they should choose. It will also help with competition, as some EV makers will need to improve in order to remain competitive. This data, most importantly, can also help civil and electrical engineers figure out the amount of electrical generation capacity which will be needed in the future based on these statistics. Now, kind of a little bit of a background. Fossil fuels are a non-infinite resource and need alternatives. While we have probably centuries left, that figure is debated. It is the world is slowly going to shift to EVs because they're more efficient and they're sustainable. Humanity's greatest achievement will be building an efficient zero-emission system to handle the industrial backbone of society. Now, this data was collected from the European market, featuring over 100 models. It includes many details such as drivetrain, energy efficiency, and price in euros. A significant number of these vehicles are also available in the USA, and this is the source for the data. Now, question. Is there a difference in mean energy efficiency between low-priced and high-priced electric vehicles? For this data set, U1 will be the mean efficiency for low-priced EVs, and U2 will be the mean efficiency for high-priced EVs. I split the price at $45,000 for low versus high priced, as this is somewhat the midpoint in the data, and it's also close to the average new car price, and it just seemed like the most reasonable spot to split the data. Now, as I said, group 1 was low priced, group 2 was high priced. Our sample mean, was 173.71 watts per kilometer for low priced. Our standard deviation was 15.32 watts, and we had 55 vehicles in our data set. For high priced EVs, our sample mean was 206.88 watts per kilometer. Our standard deviation was 32.06, and we had a 48 vehicle model subset. Now for our hypothesis test, U1 does not equal U2. For H0, H1, U1, I got that backwards. H0, U1 equals U2. H1, U1 does not equal U2. For this, it made the most sense to use a two-tailed test because of that. T distribution. So that means our degrees of freedom is 65. So that means T equals 6.55, making our P value incredibly small at 1.07 times 10 to the negative 8th. Now for the conclusion, we reject the null hypothesis at A equals 0.05 because of that. There's enough evidence to conclude there's a significant difference in energy efficiency between low-priced and high-priced EVs. Low-priced EVs are, on average, more efficient than high-priced EVs, as you can see in this chart I made here. Now, the reason for this, which I would assume, is because high-priced EVs are often dual-motor or tri-motor, making them, on average, a lot more inefficient, but a lot more luxurious and more powerful. Now, there is a lot of crossover, and there were some really efficient high-priced EVs, such as the Lucid. And, these were just interesting statistics to look at. This is my project. Thank you for watching.